Shri Gurubhyo Namaga children, welcome to our online teaching academy Ekalaiva. Today we are going to discuss in exercise 9.3 question number 19. Find the sum of the product of the corresponding terms of the sequence 2, 4, 8, 16, 32 and 128, 32, 8, 2, 1 by 2. See the required sum first. Sum equal to, they said product of the corresponding terms. That means 2, it will match with 128. 4, match with 32. 8, it match with 8. 16, match with 2. 32, it match with 1 by 2. Sum of the product. That means in between addition symbol you want to apply. That is 2 into 128 plus 4 into 32 plus 8 into 8 plus 16 into 2 plus 32 into 1 by 2. Right? Product of the corresponding terms of the sequence. For that sum you want to find. The statement we are converted into the number format, numerical format. That is 2 into 128, 4 into 32, plus 8 into 8, plus 16 into 2, plus 32 into 1 by 2. Here I am going to take 64 as common. 64 as common. If I am taking 64 as common, I can get the term, what it is going to exist inside the bracket. No, it represents our GP. 64 if I am taking as a common, what should be inside the bracket? 4. Next 2 plus 1. Right. 64 into 4, 256. 64 into 2, what can you get? 128. 8 into 8, 64. Now, here 32 is there, but I took 64 as common. So, what it should be? 1 by 2, right? Again, here I took 64 as common. Here what it should be? 1 by 2 square. Got it, children? 1 by 2 square, that is 4. If you divide by 4, what can you get? 64 as common, right? If you divide it by 4, 16. The same thing you arrived here also. 13 into 1 by 2 is nothing but 16, right? 16 into 2, 32. 64 divided by 2, 32. Without affecting the previous step, I modify the format. I modify the format as 64 into 4 plus 2 plus 1 plus 1 by 2 plus 1 by 2 square. The bracket, it represents our GP. The bracket, it represents our GP. How can I say the second term divided by first term? What can I get? 2 by 4, 1 by 2. Then 1 by 2. Third term divided by second term. Fourth term divided by second term. Fifth term divided by fourth term. The same result I am getting. The common ratios are equal. That's why I said it represents GP. Right? See here. The curly bracket, right? 4, 2, 1, 1 by 2, 1 by 2 square form is a GP. The curly bracket. That's why I mentioned as a curly bracket there, right? Now, what is my A? A equal to 4. What is R? R equal to second term divided by first term, that is 1 by 2. Yes, how many terms are there? That is Sn, right? Sn equal to formula A into R power n minus 1 divided by R minus 1. Here how many terms are there? 5 terms. That means R how many? 5. Sorry, n equal to 5. Right? Now, S5 equal to A is 4. 1 by 2 the whole power 5 minus 1 divided by 1 by 2 minus 1, which is equal to 4 into 1 minus 32 divided by 32, the whole thing divided by minus 1 by 2. Got it, children? 2 power 5 is nothing but 32. Now, which is equal to 4 into minus 31 divided by 32. Here the denominator as a fraction, it will act as a reciprocal, that is minus 2, right? 2, 16. Then 4, 4 are. So your S5, the bracket amount how much? Minus into minus plus 31 divided by 4. 31 divided by 4. Now the required sum is equal to required sum equal to 64 into S5. 64 into S5. That is 64 into 31 divided by 4. 4 ones are then 16. 16 into 31. 16 into 31. 496. Right. Now I am going to move to the next question. That is question number 20. Show that the product of the products of the corresponding terms of the sequence sequences A, AR square, etc. AR power n minus 1 and capital AR square, etc. AR power n minus 1 form a GP. And find the common ratio. First, what we want to show it represents GP. GP means what you want to say, the common ratios are equal means it forms a GP. It has to be proved that solution it has to be proved that the sequences product, they said no, sequence A into capital A, comma, AR, capital AR, AR square, capital A, capital R square, etc. AR power n minus 1, capital A, capital R power n minus 1 forms a GP. Now I am going to say the common ratios are equal, right? Second term divided by first term. Second term divided by first term. What is my second term? capital A, capital R divided by small a, capital A. A cancel, capital A cancel, then common ratio is R into capital R. Now we'll pass on to the next. Third term divided by second term. Third term divided by second term. If you arrive small r capital R means it forms a GP, right? Third term is what? A R square capital A capital R square divided by A R capital A capital R. A cancel, R 1 cancel, capital A cancel, capital R, here it becomes 1. So you arrive the result as R into capital R. Like that you can go, right? You will get the same result as R. Here the common ratios are equal, therefore it forms a GP. The above sequence, thus the above sequences, the above sequence forms a GP and the common ratio is small r capital R. Common ratio is small r capital R. They said the product of the corresponding term of the sequence forms a GP. Then they are asking to find what is common ratio. Both we did. Got it, children? To receive our online lesson, please press the subscribe button and you will receive the latest updates. Thank you, children.